Bismillahirrahmanirrahim. Exercise 3.4, question number 1, part 14. Integral x sine inverse 6 dx. The formula for integration by parts, integral f of x g of x dx, considering f as first and gx as the second function equals to first function constant integral of second minus integral derivative of first function into the same integral, this integral again here, bracket close, and dx. The previous results which you must know are integral x dx equals to x square by 2 plus c. Derivative of sine inverse x is 1 by square root of 1 minus x square, and integral of 1 by square root of 1 minus x square dx equals to sine inverse x plus c. Let's start the integration. So we have to decide, we name the integral as I, let I be the integral name of the integral. Let's consider sine inverse x as the first function and x as the second function, and apply integration by parts. So let's see, what do we get? We get, here it is, first function constant, that is sine inverse x as it is, integral of second function minus integral derivative of first function, that is d by dx of sine inverse x into the same integral x dx, bracket close, and we have a dx. Now let's see, this is equal to, write both results from the sidebar, and you get sine inverse x into x square by 2 minus integral derivative of sine inverse x is 1 by square root of 1 minus x square, and integral of x dx is again x square by 2, and then we get this dx. Now rearrange it, x square by 2 sine inverse x minus, bring this 1 by 2 outside, and you have x square by square root of 1 minus x square dx. Now I'm going to name this integral as I1, and we get integral I is equal to x square by 2 sine inverse x minus 1 by 2 into I1, where I1 is equal to integral x square divided by square root of 1 minus x square dx, and for further reference we are naming this result as result number 1. Now we have to perform this integral, we have to evaluate this integral. For that I'm going to add and subtract 1 to this numerator. So let's see, what do we get? We get I1 is equal to 1 minus 1 plus x square divided by square root of 1 minus x square and dx. Now I take this negative sign common, and I get integral 1 minus x square divided by square root of 1 minus x square and dx. Split up this these two fractions, and you will get this thing, 1 by square root of 1 minus x square minus 1 minus x square divided by square root of 1 minus x square, and outside the bracket we have a dx here. Now this thing, 1 minus x square divided by square root of 1 minus x square, using the basic result of algebra, this result we are going to write this as integral 1 by square root of 1 minus x square, and this can be written as 1 minus x square inside the square root, and I have also opened up the bracket, so we get a dx here and an integral sign and a dx here too. We open up the bracket, and meanwhile we write this 1 minus x square divided by square root of 1 minus x square like this. And now this integral, you know this integral, it is equal to sine inverse x. And what about this one? we are going to name it as I2, where I2 is equal to integral square root of 1 minus x square dx, and for further reference we are going to name this as result number 2. Now we can evaluate this integral in two different ways. Let's see. We can evaluate this integral by substitution. We can evaluate this integral by integration by parts. I'm going to demonstrate both these methods for you, and then you will make your own choice when you will be solving this question, whether you want to do by substitution or you want to do by integration by parts. For substitution, we take the substitution x. I have written all the important results here, and we take the substitution x equals to sine theta. As a result, dx becomes cos theta d theta. Square root of 1 minus x square becomes square root of 1 minus sine square theta, and then it becomes cos square root of cos square theta. As a result, square root of 1 minus x square becomes cos theta. Now put all these values in this integral and you will get integral I2 is equal to integral square root of 1 minus x square becomes cos theta, and dx becomes cos theta d theta. As a result, it becomes integrals cos square theta d theta. Put cos square theta equals to 1 plus cos 2 theta by 2. So integral I2 takes the shape 1 plus cos 2 theta by 2 and a d theta here. Take this 1 by 2 common and you will have, and also split up the integral, or open up this bracket and you will get 1 by 2 outside, and we get one integral with d theta and the other integral with cos 2 theta d theta. Now perform integration. This result is equal to theta and this result is equal to sine 2 theta by 2. And also this is the last perform integration. So we introduce a constant of integration C1 and then 1 by 2 theta. Use the value of sine 2 theta, which is equal to 2 sine theta cos theta whole divided by 2 plus C1, and we cancel both these 2's. Here it is. And now what we are going to do, we are going to put the values of these. Let's see what is the value of theta. From here we get theta is equal to sine inverse x. So in place of theta, put sine inverse x. In place of sine theta, put x from here, and in place of cos theta, put square root of 1 minus x square. And from here we have C1. So this is the value of I2. Let's get to the value of I2 by let's evaluate the value of I2 by integration by parts. For that, consider it like this. I'm using a different color for it. Consider integral I2 is equal to integral square root of 1 minus x square into 1 into dx. Perform integration by parts by using this as the first function and this as the second function, and you will get integral I2 is equal to first function constant, integral of second, minus integral, bracket starts, d by dx, derivative of square root of 1 minus x square into the same integral, bracket close, and we have a dx. So what do we get? 1 square root of 1 minus x square. All these results are mentioned here. Integral of 1 dx becomes x minus integral. This result, you can see d by dx of square root of 1 minus x square is equal to minus x divided by square root of 1 minus x square, and this result is equal to x, and then we have dx. So what do we get? On the whole, we are going to get x into square root of 1 minus x square minus, inside we have minus x square divided by square root of 1 minus x square and a dx. Now again add and subtract a 1 here. You will get x into square root of 1 minus x square minus integral 1 minus x square minus 1, add a 1 and subtract a 1. divided by square root of 1 minus x square, and you have a dx here. Now split this fraction and you will get x into square root of 1 minus x square minus integral. Inside the bracket you will have 1 minus x square divided by square root of 1 minus x square minus 1 by square root of 1 minus x square, and we have a dx here. So and all these are equal. This is equal to I2. And then we get I2 equals to x into square root of 1 minus x square. This becomes square root of 1 minus x square, and this is minus 1 by square root of 1 minus x square. We also open up the bracket and we get two integrals. One integral is this, and then minus and minus gives me plus, and this is my second integral. Now this result is equal to sine inverse x. And what about this one? This is equal to I2 plus sine inverse x. And as this is the last integral performed, so we write a constant of integration. So I2 is equal to this. Bring this I2 towards this side, and on this side you will have I2 plus I2. When this I2 comes to this side, you get this, which is equal to 2 times I2. So I'm writing it as 2 times I2 is equal to x into square root of 1 minus x square plus sine inverse x plus c1. And now you can evaluate. I2 is equal to 1 by 2. Inside the bracket we have x into square root of 1 minus x square plus sine inverse x plus c1. Now compare the two results. You can see we get the same result from both the integrals. And what is the next step? We have to put this result I2 in I1. Whether you do by this method or you do by this method, you're going to get I2 equals to this. And now put it in the result number 2. This is result number 2. I have written it here. So I1 becomes, I better use the blue color because I'm back to my normal solution. I1 is equal to sine inverse x minus 1 by 2. Sine inverse x, and then sine inverse x, or what was the value of I2? I must confirm the value, plus x into square root of 1 minus x square plus c1. Open up the bracket, you will get sine inverse x minus 1 by 2. Sine inverse x minus 1 by 2. X into square root of 1 minus x square and minus c1 by 2. It is equal to minus c1 by 2. Now sine inverse x minus 1 by 2 sine inverse x. It simply becomes 1 by 2 sine inverse x, and then I have this, and then I have minus c1 by 2. Now put in result number 1. Here is result number 1, and what do I get? Integral I is equal to x square by 2 sine inverse x minus 1 by 2 into I1, and this is I1, just put the value here, 1 by 2 sine inverse x minus 1 by 2 x into square root of 1 minus x square minus c1 by 2, and just open up the bracket and you will get your result, which is equal to x square by 2 sine inverse x minus 1 by 4 sine inverse x plus 1 by 4 x into square root of 1 minus x square minus c1 by 4. All you have to do is put c1 by 4 equals to c, and you get x square by 2 sine inverse x minus 1 by 4 sine inverse x plus 1 by 4 x into square root of 1 minus x square plus c, and that completes the solution, and this is our answer. Here it is.